Okay, hi guys. So let's proceed with our final subtopic for chapter 4, tutorial 4.4 about inverse functions. Take a look at the notes. The notes is very simple, but it's okay. I will further explain on the whiteboard later. So inverse function is a function that reverses another function. So as you can see, this is the arrow diagram of fx, the original function, a mapped to 3 and so on. So if it goes the other way around, so it's going to be f inverse. So just now we have a mapped to 3, but this time 3 mapped to a, so we call it as f inverse. So this is notation of f inverse. This is the original one before. Okay, so let's go to whiteboard to have further explanation.
So let's proceed with our final subtopic for chapter 4, 4.4, inverse function. Okay, to talk about inverse function, you need to make sure that the function given to you is one-to-one and onto function first to have an inverse. To have an inverse. So if the function given to you is not one-to-one or not onto function, there is no inverse for the function given. Okay, so still remember onto function? Onto function happens when range equals to codomain. Okay, easily you can find out about this one from the arrow diagram. Okay, still remember one-to-one? One-to-one is the relation. Easily we can find out that one based on arrow diagram as well. Let's recall it back. Let's say you have arrow diagram like this, A, B, C. This here we have, for example, 1, 2, 3. Okay, let's say I do the mapping. A goes to 1, B goes to 2, C goes to 3. Let's say this is fx, the diagram of fx function. Okay, so this one you knew already that this is 1-to-1, right? Okay, this is 1-to-1 relation, but double check, is this onto function? Yes, it is. Why? Because every single y here being mapped by x, so these are your range. Your range are 1, 2, 3. All together here are your range, and we knew already that all together in your right hand side is your codomain. So range is 1, 2, 3, codomain are 1, 2, 3 as well. So range and codomain are similar, therefore this one is onto function. So once we have fx as one-to-one relation and onto function, therefore we have an inverse. Okay, so I give you another example. Let's say we have a, b, 1, 2, 3. So this one is function gx. A mapped to 1, B mapped to 2, but nothing mapped to 3. So this one we knew already that this is 1-to-1, but our range are 1 and 2, and codomain are 1, 2, 3. Therefore our range and codomain are not similar. Therefore this one is not onto function. Since we need to have one-to-one and onto function first to have an inverse, therefore in this case no inverse function. So in another word, G inverse does not exist. Because of what? Because the function gx is not onto function. That's how the inverse of a certain function exists or not. So let's proceed with one-to-one function. Recall it back, the one that you learned in 4.1, the first subtopic. Still remember VLT? VLT is vertical line test. Vertical line test is to determine a function given is a function or not a function. So that's the purpose of doing VLT. Okay, because I'm talking about this one because one-to-one, to get one-to-one function, to determine a function given to you is one-to-one or not. There are two tests to obtain one-to-one function: by using graphical or by using algebraic. What does it mean? If given to you a graph and then you can spot on either the graph given to you one-to-one or not by using graphical method. How? Graphical method, we will use HLT, horizontal line test, instead of vertical line test. So please bear in mind that you do vertical line test to test it is a function or not. You do horizontal line test to test the function is one-to-one or not. Okay, and then of course we can do algebraically by using the formula of f a equals to fb, and then it will implies a equals to b. If not, it is not one-to-one function. Let's do examples to proceed with the understanding of testing one-to-one function. Okay guys, this is the given example. Determine fx 1 minus x square quadratic function is a one-to-one function or not. And then hence, the second part of the question, hence find f inverse if possible. If not, give a reason why. Okay, so then let's proceed with the first part. As I told you before, to test it either one-to-one function or not, you have two methods, algebraic or graphically. So algebraically, this is the formula guys. Formula is fa equals to fb. So what does it mean? Your left hand side is substitute x with a, so 1 minus a square. Your right hand side is fb, so 1 minus b square. So simplify this one. So 1 and 1 can be cancelled off, minus can be cancelled off. So leave you with a square equals to b square. Be careful guys, these two you cannot cancel off, square and square. Why? Because actually by bringing square to the other side, you get a plus minus set b square. So means that if you cancel off these two, you get a equals to b, and another one a equals to minus b. So since we have two conclusions here, therefore it is not one-to-one function. Once again, we can only conclude that the function is one-to-one if the conclusion is only a equals to b. If you get even a equals to b with the other answer, it is still not one-to-one. It can only accept a equals to b for it to be one-to-one function. So we prove it algebraically already. If you don't want to use this method, not going to be a problem. You can use graphical method, algebraic, graphical. To do graphical method, you need to sketch the graph. So I'm gonna skip the method on how to sketch the graph because I taught you already, right, about this one. So the graph will be like this. Y, X is going to be set 1 somewhere here without B. So something like this. This is the graph. Once you get this graph, graphically actually by using HLT, which is horizontal line test. Simply draw a horizontal line passing through the most points possible against the graph that you did just now. So this is the graph. So let's say this is my HLT, horizontal line test. As you can see, we have two intersections. We can only accept one intersection. One intersection, therefore it is one-to-one. Two or more intersections, not one-to-one. So it's going for similar conclusion. It is not one-to-one function. You can either use algebraic method or graphical method, which is horizontal line test. Okay, so done with the first part. I erased already the part that we are dealing with graphical horizontal line test just now. Let's say I want to make it algebraic method only. Okay, so this is my solution for the first part, and then the question asking you, hence find f inverse is possible, if not give a reason why. Okay, since our conclusion from the first part is it is not one-to-one function, therefore f inverse does not exist. Why? Since fx is not one-to-one function. So this is the reason why. So that's it, done already with the second part. Okay guys, example, determine y equals to 2x minus 5 is a one-to-one function or not. Hence find f inverse if possible. If not, give a reason why. So given to you a linear function, to test it is one-to-one function or not, we have two options. We can use algebraic or graphical method. So algebraic method, we have fa equals to fb. This is the general formula to prove it. So means that fa, what does it mean? This is your actually fx. Okay, you can change your y fx. So you can simply change it to fx. So fa, what does it mean? 2a minus 5. fb, 2b minus 5. So these two can be cancelled off. Minus 5 cancel off, so leave you with 2a equals to 2b, 2 cancel off, so obviously you get a equals to b, so it is one-to-one function. One-to-one function. But if you didn't wish to proceed with algebraic method, you can do graphical method, means that we are doing horizontal line test. Graphical method, let's draw this one. The y-intercept is minus 5 is somewhere here. The gradient is positive, so towards the top right. This one is your graph. Y equals to 2x minus 5, this is your graph. So let's draw any possible horizontal line test to determine either it is one-to-one function or not. Let's say this is my HLT. You can see only one intersection. Only one intersection, therefore it is one-to-one function. So similar conclusion to the one that we did with algebraic method. You can either do this method or do this one. Okay, no need to put both. Okay, let's say you want to do the graphical part only. Okay, so I erased already the algebraic method. For us to proceed with the second part. Hence find f inverse if possible. If not, give a reason why. It is possible, guys, because we have proved that it is one-to-one function. So since it is one-to-one function, it's going to have an inverse. So how do we find the inverse? Given to you the question, even in y form, you can change it to fx, right? So fx equals to 2x minus 5. To get the inverse is actually by doing this. F inverse x is equals to x. Guys, this is the formula of inverse. So what does it mean? Take a look at this part. Compare it with the upper part here. Fx equals to 2x minus 5. To make it clearer, I can change x to box. So now my box here becomes f inverse. So what does it mean? F box equals to 2 box minus 5. So what happened to f box? It's going to be 2 box minus 5 equals to x. So now we obtain this equation. Simplify until you get f inverse as your subject. Is going to be 2f inverse x, bring minus 5 to the right hand side, so becomes x plus 5. So your f inverse x, divide both by 2, so you obtain x plus 5 divided by 2. So this is your f inverse. Please denote that this is the general formula of, or we can write it down as inverse general formula. Okay guys, that's it, done already with the inverse function. Actually we have done completely with our explanations about chapter 4. So try your best to answer all the questions given in your tutorial.
Thank you.